22.4, choosing a method for solving quadratic equations. So we've looked at different methods of solving, factoring being one. So we go all the way back to the module I introduced, but also module 20, and you look at factoring as a method of solving equations. You can also go to taking the square root of both sides, which is what this deals with. We've got quadratic formula, which works for any. Just make sure it's equal to 0. Okay. And then you decide what method you want to use based on the information they give you. One that I do want to remind you about here is completing the square. And that's a little more difficult. It's something that's definitely utilized in Algebra 2, especially when we graph quadratics, because typically in Algebra 2 we use vertex form. So that becomes a very useful method of not necessarily solving for the equation, but getting it in that form. Okay, but what we're going to do is we're just going to go ahead and take these problems and we're going to try to determine what is the best method of solving. Okay, so in this first example here, because I only have an x squared, there is no x term here. Then here I'm going to do the square root method. So remember, in the square root method, first thing we have to do is get x squared by itself. So I'm going to add 100. So that leaves 9x squared equals 100. Then I have to divide both sides by 9. So then I end up with x squared is 100 over 9. Then I can take the square root. Now remember, when you take the square root, you always have two answers, plus or minus. Square root of 100 is 10. Square root of 9 is 3. So those are my two solutions, positive 10 over 3, negative 10 over 3. All right, problem number 7. Not that I like doing completing the square necessarily, but that's the method I'm going to do here. And the reason is a couple. One, that is a 1 here. And 2, this is an even number. Okay, if that's an even number, then completing the square is a method that's viable. So the first thing I'm going to do is I got to add 7. Remember, we always have to move that over. So we get x squared plus 4x plus something equals 7 plus something. That's our c. So how do we get that? Remember, you take half of the middle term. That's a positive 2. And then we square that, which is 4. So that becomes our c. Hopefully this is looking familiar to you. So then to factor this, we take that middle term, which is a positive 2, and that becomes x plus 2 squared, just like in the thing here. And then on the other side, 7 plus 4 is 11. So to get rid of the square root, or the square, we take the square root. So we get x plus 2 equals plus or minus square root 11, since I can't take square root 11. Then I get rid of the 2 by subtracting. So I get x is negative 2 plus or minus square root of 11. And remember, these are exact answers, radical answers, and you can't get those on the calculator. But remember, on the calculator, if you solve, you can get a decimal and then take your square root answers, change them to a decimal, and match them up. All right, so it goes through a word problem here. We continue with this your turn problem. So the first thing we got to do, we got to remember that we are talking about quadratics. So the basic formula is negative 16t squared plus vt plus s, where v is the initial velocity, and s is in starting or initial height or position. Okay. So the wheel of a remote-controlled airplane falls off while the airplane is climbing at 40 feet in the air. So there's our S. The wheel starts with an initial upward velocity of 24, up being positive direction, so V is positive. And then it says, how long does it take to fall to the ground? Okay, so that means our h here is 0, because ground would be 0. So I get 0 is negative 16t squared plus 24t plus 40. Now, to be very honest here, when I'm doing a word problem with this particular formula, I tend not to ever do factoring or any of the other methods. I just go straight to the calculator. Set up the equation to determine the time, then pick one method to solve it, explain why you chose that method. So it doesn't matter, but I'm going to do the calculator, and I'm going to put this in for y1, and I'm going to make it a fat line because it's on the x-axis just so I can see it. I'm going to put this in for y2, then I'm going to go to second, trace, number 5, and I'm going to do intersect. Now, you got to make sure and look here and see how many times they intersect. Since t here is time, we only need the positive answers, but there's possibility it could be 2 positive answers, but it's not going to be, and I can explain why here. Let's talk about the graph itself. Where are we starting this? Remember, the plane is at time 0 already 40 feet in the air. So it's going to fall down and hit the ground at some time t here. Well, the other place it would have been on the ground is over here, which is negative time, and that doesn't make sense. So I'm going to go ahead and put those in. So y1, remember I'm going to make a fat line. I'm going to put 0. y2, I'm going to type in negative 16x squared plus 24x plus 40. Then I'm going to go to my window, and I'm going to set my window up. So on my window here, I'm going to make x min be 0 because I can't have a negative time. X max, let's just leave it 10. Okay, I don't know how long it's going to take, but if it's bigger than that, I'll be able to tell on the graph. My y min, I've got to make it something smaller than 0 because I just want to see where it hits the x-axis. So I'm going to say negative 5. And y max, I'm going to make 45 because it starts at 40. So I want to make it something bigger than that. So negative 5 and then 45. And then press graph. So there's my horizontal line. There's my parabola where they cross. So now I do second, trace, number 5, and then enter 3 times. And it's at 2.5 seconds. So t is at 2.5 seconds. So that's how long it would take to hit the ground. Remember, negative answers here won't make sense, and hopefully you got that from the graph itself. So that's choosing different methods to solve. We didn't do all of them. We did not do quadratic formula, but you want to pick what makes sense, and we'll do some examples in class as well. All right, so there is another word problem here. I'm not going to solve it, but I do want to help set it up for you just to make sure we get this idea of how to set it up. Marco's brother Jesse is helping Marco knock a kite from the tree. He can throw the ball 50 feet per second upwards from a height of 5 feet. Is he throwing the ball hard enough to reach the kite? And if so, how long does it take the ball to reach the kite? Okay, so what we have is we have our formula, negative 16t squared plus, what's our initial velocity? 50 feet per second upwards, so 50t from a height of 5 feet, and that's because that's where he's releasing the ball. Okay, so it says Marco's brother Jesse is helping Marco knock a kite from the tree. Is he throwing the ball hard enough to reach the kite? And if so, how long does it take the ball to reach the kite? So what we set this equal to is 42. Now, where does the 42 come from? It actually comes from the explain to problem earlier in the notes. So if you go to the explain to, there's a problem in there that talks about Marco and the tree being 42 feet up. It's kind of the reason I didn't want to solve this, but I did want to make reference to it so you kind of know where it came from and how we set up the equation.